Karen Fuson hasn't been able to stay with us and has sent a video with her presentation. Karen, Professor Emerita in the Learning Science Department of Northwestern University's School of Education in Evanston, Illinois, USA, is one of the leading researchers in mathematics teaching to school-aged children. For over 50 years, she has studied how children understand mathematical ideas. She has designed teaching materials based on how children learn and understand. She has worked in schools helping teachers to teach in innovative ways that reinforce learning in all of them. Her 1998 book that some of you might know, Children's Counting and Concepts of Number, is a classic that has inspired a lot of further research. She's currently a member of the National Research Council's Mathematical Learning Study Committee, and author of the mathematics program Math Expressions, published by Houston Mifflin Harcourt. She has worked on the Common Core mathematics standards as well as on the learning progressions on these standards. She has co-authored several textbooks for teachers for the National Council of Teachers of Mathematics on essential aspects about pre-K and primary school. It's a great honor for us that, thanks to her acquaintance with Professor Anna Millán-Gasca, she has agreed to record this video specifically for this workshop, relating words, visual images, and math symbols for understanding and competence. However, it is not specific for people with intellectual disabilities. Understanding this connection will surely help us to understand this reality.
Hello, I'm Karen Fuson, and I'm sorry I cannot be there with you. To help with that a little bit, I've prepared a PowerPoint with a kind of voice annotation for each slide, and I'm focusing on 3 aspects of my research about early number with children that I think are particularly important. The first one is about 5 groups and how that helps students see numbers below 10, and later on they can use that in multi-digit addition and subtraction when they make math drawings to show multi-digit numbers. The second topic is partners hiding inside a number, that is the add-ins hiding inside a number that helps children move to level 2 and more advanced strategies. And the third one is word problems and the importance of math drawings that students make, their own math drawings, but also research-based math drawings that I found to be accessible and useful to students with all size of numbers. I'm going to be speaking about relating words, visual images, and math symbols for understanding and competence because I've done a lot of research on this issue through the years. After each main part of this PowerPoint, there is a slide with places on my website where you can find more information about each main part. My website is my name, KarenFusonMath.com. And the 3 parts about which I'm going to be speaking is 5 groups in early number and in multi-digit computation, break-apart partners, such as 5 equals 3 plus 2 for early number learning, and especially for moving to level 2 counting on math.
Disculpad, que sepáis que la comunicación, que el vídeo se colgará después en la web, entonces no es necesario, ¿vale? Que estéis.
Methods and solving word problems and how math drawings can help with representing and solving. I was asked to make a few comments about relationships between the use of concrete materials and the building of abstract concepts. I use a Piagetian theory of learning, but a Vygotskian theory of teaching with a focus on the socio-cultural tools for learning. This is not Bruner's concrete to iconic to abstract, because I don't believe you have to go through those 3 stages, especially not the iconic. I instead see in every math domain a web of connections among math words, math symbols, and visual images. These visual images can be concrete or math drawings. And this web becomes connected for users through modeling, using the web, and explaining. My research has focused on finding powerful visual images, concrete or math drawings, that work in classrooms, conceptually and practically, and then articulating the web and learning path for a math domain. Young children do need concrete things they can move, but math drawings they can produce themselves are engaging and easier to manage, and they support math talk. Kindergartners can do this for some topics, and first graders for many topics. Learning paths involve levels of increasing abbreviation, abstraction, and internalization, but the visual images remain as an accessible base. We'll be seeing this in the examples we'll be discussing. A strength of the conceptual web connected by Math Talk is that most children have at least one modality in which they are strong enough, and that modality can help support the other modalities that need to become related in this conceptual web. So explaining may be difficult for one child, but she perhaps can make drawings of her thinking. Then, with enough modeling of explaining, this will also improve. Another child might have difficulties with drawing, but can explain or enact with materials, and gradually drawing can improve. For more of my ideas about building mathematical ideas, you can find this paper in publications on my website. It's Avoiding Misinterpretations of Piaget and Vygotsky. And I sent a PDF file of this whole PowerPoint, so you can have all of these references to my website. Also in the menu section on the website, Publications, there are many more papers about conceptual webs and learning paths in specific math domains. Now we're ready for the first topic, the 5 groups, the visual 5 groups that help children understand the meaning of numbers and help them count from 1 to 10 meaningfully. Here in the yellow row, you can see the numbers 6 through 10 as 5 groups. 6 is 5 and 1, 7 is 5 and 2, 8 is 5 and 3, and so forth. And this is the same 5 groups as are on our hands. You can see at the top right there that 9 is 5 fingers and 4 fingers. And so the 5 groups are very natural to children. They have to learn that they have 5 fingers on one hand, but they can do so easily. These 5 groups are used widely in East Asian countries for children to make meaning of numbers. And down below, you can see that where the big yellow parade is a big, long thing that I call a number parade, and it's put up in the classroom so children see that all the time and they can practice it and learn it. Below is a set of activities that you can see on my website where those are 5 group tiles. There are 5 tiles, so 5 plus 4 is 1 5-group tile plus the single individual tiles. And there on the right, you can see that children can make all of the numbers from 5 through 10 using the 5 tiles and single ones. Here's another kind of 5 group that kindergarten children use. Children enjoy working with money, and pennies are easily available for use in class. So in my Math Expressions program, I also use nickel penny strips and pennies to show numbers in 5 groups. See there on the left, children will fold the nickel on the back, so there's 5 pennies on the front, a nickel on the back, so they gradually learn that, a nickel is equal to 5 pennies. Even though it's smaller than 5 pennies, it has the same quantity value. So they can then use these penny groups, we call them nickel strips, the nickel strips, to make numbers 6 through 10. A crucially important learning task for young children in kindergarten is one that's more difficult for children speaking European languages, and that is understanding the numbers, the teen numbers 11 of 2 nickels. At the top there, that's a Common Core standard, that's the numbers base 10 kindergarten standard, focusing on this really important kind of knowledge. The 5 groups are also used later in math drawings children make when solving word problems and when adding and subtracting multi-digit numbers. These 5 groups support accuracy in drawing because you can just see immediately a number. They help listeners who are listening to their friends explain see the quantities immediately, and they support the Make a 10 methods for teen numbers, such as 8 plus 6 is 8. I break apart that 6 into 2 and 4, so 8 plus 6 is 8 plus 2 plus 4. The 8 plus 2 is 10, plus 4 left from the 6, and I know 10 plus 4 is 14. That's one of the reasons it's so important to work on all the teen numbers, 10 plus 4, so you immediately know it's 14. So these Make a 10 methods that are widely taught in East Asia can be learned in the U.S. It's just simplifying, changing a problem you do not know, 8 plus 6, into a problem that you do know, 10 plus 4, by breaking apart the second addend. So here's a first grader explaining 58 plus 36. She's made a math drawing, 5 10s and 8 1s, and you see the 8 1s are in a 5 group. There's 5 circles above and 3 below. And then 36 is 3 10s and 6 1s. There's another 5 group, 5 and 1 is 6. And she looks at that and she said, I can see that I need 2 more to make a 10. And I'll take 2 more from the 6 to make a 10. And you can see her amoeba-like drawing around that, in which she takes 2 to add to the 6 to make 10. And she says, I'll put the 10 down over here on the 10 side, waiting to add the 10s, and I can see that I have 4 1s left. So the 5 groups are very useful. Everyone in the classroom can see exactly what she's doing. It supports those visual Make a 10 methods. So here is where you can find out more about 5 groups on my website, KarenFusonMath.com. There are these teaching progressions that I've made about all of the Common Core Standard domains. And they're PowerPoints where I'm doing voice narration, just like this PowerPoint that you're hearing right now. And there's OA, that's Operations Algebraic Thinking Part 2, and there's NBT, Numbers Base 10 Part 2, where you can find more about both of these parts that I've been discussing. And then also on my website are classroom videos. I just love these kindergarten videos. So if you go to the menu part of classroom videos and go to kindergarten, most of the videos are going to be about 5 groups. The children will be doing some of those activities I was showing you. You'll see a couple shots from those, and they always cheer me up seeing what kindergarten children can do. It's just so wonderful. Then here is where you can find that first grader explaining her method and other children explaining adding and subtracting for 2- and 3-digit numbers using math drawings with 5 groups. You have to go to classroom videos, then a classroom components, then the math talk, and you'll be able to see the drawings and children's explanations of those drawings. Now we're starting the second section, which is about breaking apart a number into its partners, helping children see the 2 addends embedded within the total. That lets them do more complicated strategies and just helps enrich their notions of number. So at the top there, that ABC, this is an activity that's done repeatedly early in kindergarten. Children are working individually on a cookie tray or a tray. Those are little foam numbers. They have the number parade 1 through 10 up on the wall so they can see all the numbers. So first they put their own number in order up at the top, and then they pull down a number. The whole class does it together, the whole group does it together, and so there you see 3 pulled down, and then they make that 3 however they want with those individual tiles down below. And the tiles are in 2 colors. There's a dot on one side and a no dot on the other side, so children can make the number 3 in various ways, and you can see the color makes the partners look really salient. You can see, oh, there, 3 is 2 and 1. So then once children have made this, they do various things. Here's the D. They have a math talk discussion. They relate that visual quantity to fingers, sounds, and body movements. They practice visual imagery. Close your eyes, visualize that 3 as 2 and 1. They describe different arrangements by color, dot, no dot, spatial relationships. Oh, I have 2 above and 1 below. And they change their arrangement and discuss why they still have 3. They copy the arrangement of another person. They see partners of numbers already described. They create new partners. They copy each other's arrangements. So there's a lot of math talk. It's very, very rich. So children can engage on it at whatever level. Some children still are struggling to put the number tiles in order, 1, 2, 3, 4, 5. And other children are describing in very detailed ways the number partners. And finally, they graph on a graph map, which are 2 rows or columns of 10 empty spaces. So this activity has many goals, but a major goal is seeing partners, helping children see partners and describe those partners and visualize the partners hiding inside a number. So here is a shot I took from a classroom video of kindergarten, the first video, to see how children make different arrangements and use language to discuss their arrangements. So I recommend that you watch that. Here you can see this child made the 8 with 3 single tiles and a 5-group tile. Those number cards have 5 groups on the back of them. So on the back of that 8 is a row of 5 circles at the top and 3 circles underneath. And here is another shot from that same kindergarten video, and you can see the children, each of them has their own tray. They're each making their own arrangement. At the top, you can see that someone made an 8 by 5 and 2, so that's 7. Their 8 was 7 and 1. And here on the slide, you can see that children made all these different partners. 8 equals 3 plus 5, 8 equals 5 plus 3, 8 equals 7 plus 1, 4 plus 4, 6 plus 2. That's not all the partners, but it's most of them. So at any point, you could get more systematic about seeing and writing down. Also notice that this is the first equation that I have children see in kindergarten. It's of the form with the total on the left and the add-ins on the right. So 8 is broken apart to make the 3 plus 5, or it's broken apart to make the 7 plus 1. That's why we call them break-apart partners. And this helps later in algebra because students expect equations always to have the single number on the right. And so already early they have experiences like this when they're breaking apart partners. For adding, of course, you can have the add-ins on the left and the total on the right. This slide shows kindergarten unit test, end of unit test performance for children. The top is unit 3, that's about halfway through the year. Children had been doing activities like this with things. They would use a little break apart. They would make 6 and use a little break apart stick to separate them and break them apart into the partners 1 and 5. They would record those with their cards. Later, they had worksheets that had things like this, and they would make so here in Unit 3, they see partners and they write the partners. And you can see that over 90% of the children were successful at all 3 of these tasks. Here, the next item is the 4th unit. That's a little bit later. Here, the children had to draw a line to show the partners and write the partners, and 92% of them separated this into the 6 into its 3 different partners and wrote the partners below. And down at the bottom is we introduced a Math Mountain. This is a common East Asian number bond. It's called sometimes, but I found it to be very powerful because the kids, here's the total on the top, 6 on the top and 5 and 1 is on the bottom. And the kids could just slide mentally back and forth. The 6 was actually breaking apart into the 5 and 1. So this was a powerful representation that we used throughout the program. And initially there was a little story about these tiny tumblers who lived at the top of the mountain. Every day some would go play on one side of the mountain, some others on the other side. So children would draw, so they would say 6, 5, and 1. They would draw the 5 tiny tumblers on the left and 1 on the right. And you can see them, they drew the 2 and 2 and drew the 7 and 3. They loved to make drawings of the tiny tumblers. This was a very powerful image that appealed to them. And you can see that 92% of them understood the representation and could make the drawings of quantities of the add-ins. Here's the rest of the data. Unit 4 is in the spring, and here they're moving to an equation, a partner equation. They're only writing the add-ins, but they do have to write the 2 plus 2 and the 1 plus 3. So they're starting to work with the math symbolism. In Unit 5, that's at the end of the year. In this one, they had to shade to show all the 5 partners in order, and then they had to write the 5 partners. So those numbers below were written by the children. And I find this still pretty amazing. 88% of the children could do this task. They would shade the partners and write 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1, all of the partners of 5. And down below, you can see they also were finding the unknown addend. Of course, they didn't have to. I mean, there they had in the first item, they had 9 on one side, so they could count the 9 and then just keep counting 10 to draw the 1 down below and then count the 1. So they could do those in 2 steps. But I think some children were also beginning to count on, because that's what these break-apart partners, the embedded numbers, are helping children do conceptually. So these tasks on the break-apart partners are helping children learn addition and subtraction in an integrated and visual way. Here are activities that first graders do early in the year. They either refresh their knowledge of break-apart partners from kindergarten or build that knowledge if they did not have a kindergarten in which that knowledge was built. But here we can see that they're moving beyond kindergarten. At the top, children get to see the break-apart partners and then write down the 7 plus 1. But they're also doing the partner switches of switching the order of the partners. So they're becoming flexible. They can kind of think about that bar of 8 as flipping either direction. So they're learning the partners, the partner pairs now. And then below, the 8 train is just a way to be abstract and allow the children to just focus on the number 7 plus 1 and 1 plus 7. They're seeing them, that each pair of numbers is in the opposite order. And the same thing with the math mountains at the bottom. The 7 1 partners are above the 1 7 partners. So children fill these out and discuss all of the patterns they see. Partners reappear in grade 4 with fractions. There is a Common Core standard about that. And here's a little story scenario in which 2 students are shelving books, and how many different ways can they shelve these books? They could do it as 1/5. One student does 1/5, the other student does 4/5, or they could do 2/5 and 3/5, 3/5 and 2/5, 4/5 and 1/5. And you can see there, if you look on the top right, the tops of the equations, it's just the break-apart partners that children did in kindergarten. 5 equals 1 plus 4, 5 equals 2 plus 3, 5 equals 3 plus 2, 5 equals 4 plus 1. This task has several benefits. For one, it focuses students on the unit fractions and what are fractions made of. They're made of unit fractions. And another advantage is when students add fractions, they make the typical error often of adding the tops and the bottoms. So 1/5 plus 4/5 would be 5/10. And here, what they're learning is when they're adding these fractions, or actually writing the break-apart partners, everything just stays fifths. The 5 is written on the bottom because all of the time they're dealing with the fifths as the unit fractions, and they get to see that in the drawing. This task also emphasizes that 1 is n over n, here 5 over 5, and also gives this feeling to students, oh, those partners I did in kindergarten, here they are again. It makes fractions a more comfortable topic. Knowing the partners can help children embed the 2 addends within the total and thus count on. Here is showing the 3 levels of strategy, moving from count all, those addition is on the left, subtraction in the right column, from count all to count on to the recompose, make a 10 methods. And you can see in that second row the count on, where if children are going to just count on 8, 9, 10, 11, 12, 13, 14, those 8 have to be embedded in the 14. They cannot be separate as they are for counting all. And so this is one of the main advantages of working on so much on the break-apart partners, is children can move to this counting on level and then be doing these more abstract forms of counting, and this helps them deal with teen numbers for addition or subtraction. For subtraction, they can count on to find the unknown addend 8 plus how many is 14? 8, I took away 8, 9, 10, 11, 12, 13, 14. Oh, that's 6. 6 more to make 14. The break-apart partners also are needed for the make-a-10 methods. You have to know all of the partners to 10. So if it's 8 plus how many to 10, you have to know the partners to 10 for all of the numbers. Then for the second addend, you have to be able to break apart that second addend into the amount that makes 10 and the leftover amount. So you have to know the break-apart partners for all the numbers. So working on break-apart partners helps give kids the prerequisites for making a 10 methods. So here's where you can find out more about partners and levels of adding and subtracting. There's a teaching progression with lots of details. The second thing there is a classroom video showing children doing these methods. And then there's a visual presentation about it with some data about addition and subtraction word problems. So now we're moving to the third part of this presentation, focusing on word problems and the importance of math drawings in word problems. So children make their own math drawings. They just make circle drawings. I'll show you some in a couple of minutes. But also I spent a lot of time figuring out, so for each of the problem types, what is the most powerful drawing we could teach children that all of them could use. And so here are the word problem situations. Across the top are addition, subtraction, the add to, take from, put together, take apart, and additive comparison. And then across the bottom are multiplication and division word problems. I'm going to focus just on addition and subtraction. So I tried various things for the add to, take from, but really those are just equations. They're action focused. It's the arrow, start plus change equals result. So we just have, even kindergarten children are using equations for that kind of problem. There in the top middle, there you see the break-apart partners, the math mountains, and so children use this drawing to put the total on the top and the addends below. And then for additive comparison problems, they make compare bars with the big number on the top, the small on the bottom, and the difference is that oval. One big advantage of these drawings is that they can be used for all numbers. So once children learn them, they can put in any size numbers, large multi-digit numbers, fractions, decimals. So it provides a consistency to the representations, the problem representations, and solutions they're making with all numbers. So here is a conceptual web of connections kindergarten children must build to solve word problems. They have to connect these 4 things. They have to mathematize real-world situations. Say, what are the quantities? What are the actions in the real world? What am I supposed to focus on? That's mathematizing. They have to learn and use mathematical language to refer to those parts of the real-world situations. They have to learn written mathematical marks and connect them to the language and to the real-world situation. And they have to learn situation and solution representations and connect them to all of the above. So in this drawing, the ABC above are what I do in my kindergarten program. Unit 1 is A2, so it shows the progression of how children build their mathematizing more and more complex real-world situations, how they move from concrete objects to drawings in the situation and solution representations, and connect written marks and mathematical language. You can read more about this in publications and things on my website, but this is an example of the complex task that children need to do, but they can do it with our help. So here finally are some math drawings by kids. These are from very low achieving school, class A's on the left, class B's on the right. There were more kids. This is just enlarged so you could see the drawings. And the problem was a put together addend unknown. Rosa picked 6 carrots, her sister picked some 2. Together they picked 10 carrots. How many did Rosa's sister pick? You can see that children in Class A mostly just use these circle drawings. We don't know whether they were counting on. We don't know exactly. You can see there's some 5 groups there. But in Class B, they used a wider range. There's the break apart partner at the top, 10 breaks apart into 6 and 4. There's equation forms, and there at the 1, 2, 3, 4th from the bottom, you can see that's a count on. There's 6, and the unknown is there, and you can see 1, 2, 3, 4. The child probably counted on to make 10 and then wrote 4. So these are good, powerful tools we're giving children, but children can also just make their own math drawings when the numbers are small, like this. Here are drawings by grade 2 children of the most difficult kind of word problem, the take from start unknown problem. Yolanda had a box of golf balls. Eddie took 7 of them. Now Yolanda has 5 left. How many golf balls did Yolanda have in the beginning? So this is difficult because you don't even know what number to start with. You have to understand the relationship of the addends to the total in order to solve this problem or represent it. So let's look at the solution at the top left there. The student writes an equation for this problem. Box, that's the unknown, some unknown number minus 7 equals 5. So that's a good problem representation using an equation. Then he makes the math drawing. Look, he uses 5 groups. And first there's 5, so he's undoing this equation, and then 7. And so he's essentially adding 5 and 7. He can see the 2 5s make 10 and 2 more make 12. So he had to have 12 to start. In the second problem, the problem on the right, there's a break apart math mountain with the 2 addends at the bottom and the total is at the top. And the student actually writes, I put the golf balls back together. Knows that those 2 addends were broken apart from that total. And so if he puts the addends back together, he'll get the total at the top. And now at the bottom, the student does not really even represent the problem, just moves to a computation, understands that the 2 addends go together to make the total, and so just adds them, but labels that 12 in all so that we know that that student understands the problem representation. I want to end with a final plea. Do not inflict number lines on young children. The National Research Council reports recommend that number lines do not start until grade 2, and then in the context of length. So we're focusing on length units. So here are conceptual connections that have to be made for count number and measure number. At the top, you see a number path. That's counting things. So I've put the numbers on those things. Number paths are often used in games for young children. Bob Siegler's research is about number path. Other people say he's using a number line. He is not using a number line. The children are counting things, not lengths. But you can see in the number line, look at how even our eyes are drawn to those numbers. Our eyes are drawn to things. So children focus on those points, but really those are endpoints of the length. They should be focusing on lengths. So what conceptual connections do children have to make between counting and cardinality? Look at that third row. When I'm counting on that number path, I count 1, 2, 3, 4, 5. And the referent there for the 5 is a count number. It is just that 5 where I pointed to that object and said 5. But then children have to make this connection to the cardinal meaning. What is the cardinal meaning of 5? It's all 5 of those things. So this very important count meaning to cardinal meaning connection is one of the early major conceptual constructions young children make. Now look below, you make the same thing for the measure, but you're counting those unit lengths there, although it's hard to focus kids' attention on them. And at the very bottom there, you have to make the connection between the 5, the unit length where I said 5, and the 5 unit lengths so far. So each of those numbers on the number line is an end point of a unit length. But in all the uses of the number line, it's really important to focus children on the unit lengths. You cannot add and subtract or do other operations on number lines without focusing on the unit lengths. And here's where to find more about drawings for word problem solving and levels of adding and subtracting on my website. There's a teaching progression, OA Part 1 and Part 2. There's classroom videos about single-digit addition and subtraction, Parts 2, 3, 4, 5. Thanks for listening and watching. And sorry I'm missing the talks and discussions. If you have questions or comments, please call me or email me, and I'd be happy to continue the discussion. And I'm sure you are all having a wonderful time.